Hello everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, आज से इस सेशन में मैं स्टार्ट करने वाला हूं discussion of 24 most important questions of COA for GATE 2024. So, uh, this will be questions from 5 different topics. So we all know that we will discuss from the machine instruction and addressing mode. We will discuss from the ALU data path and control unit. We will discuss the questions from instruction pipeline. We will discuss the questions from memory organization, and we will discuss the questions from IO interface, that is DMA, right? So these are the 5 most important things from where the questions can be asked in COA. Now, the idea is that I will discuss the type of questions. I mean, obviously, there will be previous year questions, but the idea is that concepts are repeated in the GATE exam. So, though we know that the questions will not get repeated, but the concepts are limited, therefore, the concept will get repeated. So, if you are able to understand these 5 questions by yourself, or basically, if you are able to understand these 5 questions which I am going to discuss in today's session with full clarity, then I'm sure that you will be able to solve some other questions of this particular topic also. Very good evening, Tushar. Right? So that's the objective, that I'll just give you a view that what type of questions can be framed, how do you approach them, what are the different topics from each and every one of the chapter of computer organization and architecture. Right? So today we are going to start the discussion with machine instruction and addressing mode. So obviously, what are the important topics? Are instruction format. A good quality question can be framed on the concept of instruction format. A good quality question can be framed on the concept of addressing mode. A question can be framed on the basis of different types of instruction, 3 address instruction, 2 address instruction, how instructions are executing, right? So I'll include that type of question also, right? So that's the idea, that what are the different topics which you need to understand with full clarity, and you will be able to cross check whether you have understood the question in the appropriate manner or not. In the end, when I'm done with all the sessions of top or most important 24 questions of GATE COA for GATE 2024, I'll have a mock test of 24 questions. Obviously, those questions will be entirely different. I mean, those are not the questions from GATE PYQ. So stay attentive, try to attend all these sessions so that you will be able to overcome the phobia of COA if you are having it. Okay. So guys, let's start. So this is brief introduction of myself. My name is Vishal Ravatia. I have 10+ years of teaching experience. Following are the achievements and areas of expertise. This is my Telegram group. All the PDFs, whatever the questions, if you want, if you have any doubt related to GATE CS preparation or GATE DA preparation, then you can contact me at this particular Telegram group. I'll be happy to solve your problem. Okay. Now, these are some announcements from the BYJU'S exam prep team. So, BYJU'S exam prep is going to conduct a national scholarship test on 29th of October, that is the coming Sunday. This will be conducted between 9 a.m. to 9 p.m. Do participate in this test, and you may avail up to 90% off on all the programs. Those are being offered by the BYJU'S exam prep. Apart from that, Richa Gupta ma'am is going to conduct a workshop on 25th of October at 7:30 p.m. in that particular workshop. So this particular workshop is for GATE 2025 aspirants. So if you are planning for GATE 2025, if you are a GATE 2025 aspirant, then this workshop is for you. Ma'am is going to discuss the detailed preparation strategy, that how you can ace the GATE 2025 exam, right? So both of them will be conducted on the BYJU'S exam prep app. So you just need to download the app and register yourself using your mobile number, and you will be able to participate, right? Apart from that, for GATE 2024 aspirants, the mega mock test is being conducted. The next test for computer science will be on 28th of October. That particular test will be of the topic programming, data structure, algorithm, and operating system. Do participate in this test. It will be a 65 question test of 100 marks. Overall duration will be 180 minutes. So basically, this test will help you in improve on the time management skills. So this is very important. So no matter how much you have studied, how many concepts do you know, but if your time management skill is not good, then you may face difficulty while sitting in the examination hall at the day of final examination, right? So please make sure that you have gone through at least 10-15 mock tests of 3 hours duration, so that you will know that how you can select the question, how you can overcome the problem of time management, which is generally faced by most of the students, right? So the next test for you will be on 28th of October. Do participate in this test. For that also you need to register on the application. Now the link for the registration is available in the description. You can download the application from using that link and register yourself, and you all can participate in the above mentioned activities. Okay guys, apart from that, the GATE 2024 crash course, that is the revision course, is going on, so you can choose that course, as well as if you are GATE 2025 and GATE 2026 aspirant, then for CSE we have launched the course for that also. You can enroll yourself into that particular courses. Now, so this is the very first question from the concept of instruction format. I know, so please try to understand, there are some general things. Instruction format is a damn easy concept. It's a damn easy concept. The only thing is that you may get confused because of certain things, because generally and that's the situation in this particular question. Generally you guys will assume that okay, the opcode will expand, opcode field will expand all the time, but it is not necessary. Opcode need not expand all the time. If opcode is expanding, then the methods will be different. If opcode is not expanding, then the method will be different from your perception, right? Otherwise the method will remain same. There is no difference. Let me explain by utilizing the same concept. What will happen? Sir, if the opcode field is expanding, then by how many bits the opcode field is expanding? 2 raised power the number of bits by which the opcode field is expanding, that will get combined with all the free opcodes of the previous pattern, and you will be able to identify the number of instructions of that particular type. So let's look at the question. Our processor has 16 integer registers, 16. So to represent 1 out of 16 register, you will require 4 bits in the instruction format. Now 64 floating point registers, so to identify 1 out of those 64, you will require 6 bits in the format. Now it uses 2-byte instruction, so every instruction will be of 2 byte. Please try to ensure that in a machine the size of instruction will remain same until unless it is not being specified that some instructions are of 1 word, some instructions are of 2 word. If not explicitly specified, then you will assume that all the instructions are of same size, right? So that's one thing. So the size of every instruction will be 2 byte, that is 16 bit. There are 4 types of instructions, 4 categories of instruction. One will be type 1 type instruction, type 2 type instruction, type 3 type instruction, and type 4 type instruction. So first of all, we know that all the instructions will be of 16 bit. So let me represent them so that it will be easier. Type 1, type 2, type 3, and type 4. So these are the 4 type of instructions. We know in all the instructions the size of instruction will be of 16 bit. Good enough, sir. The size of instruction is not going to change. The size of instruction will be 16 bit, whatever the type of instruction is, right? You just need to see that by how many bits the opcode field is expanding with respect to one when you move from one to another. Now the very basic thing which you need to understand is that you need to start with the type of instruction in which the number of bits available for the opcode are minimum, right? So let's read the question in detail and we will understand. Type 1 category consists of 4 instructions, okay, each with 3 integer registers. So if you have 3 integer registers, 1 integer register requires 4 bit. So I know that for type 1 instruction, the operand will require 12 bit operands. 12 bit for operands. Please try to understand. This is very important thing so that you know that from where to start. 12 bit for operands. The type 2 category consists of whatever the number of instructions, each with 2 floating point registers. So do you understand that each floating point register will require 6 bits. So 2 floating point register will again require 12 bits. So do you realize that in type 1 and type 2, number of bits available for the operand will remain same. So number of bits available for the opcode will also be same. Clear? So that's the next thing. Now type 3 instruction, type 3 category consists of one integer register and one floating point register. So for one integer register 4 bits, one floating point register 6 bits. So overall the number of bits required for operands will be 10 bits. Clear? 10 bits. Now in type 3 instruction, what type 4, sorry, in type 4 instruction what happens? It each with one floating point register. So only one floating point register is required in type 4 instruction. So the number of bits will be 6. Now please try to understand, in type 1 and type 2 the opcode field is of 4 bit. This is 4. This is also 4. No matter which one you select first. So if the minimum number of bits are required for the type 1 and minimum number of bits are required in the opcode field for type 1 and type 2, and the number of bits are same. So either you can choose type 2 first or you can choose type 1 first. It will not affect the overall solution, right? But you cannot start with the instructions which are having more number of bits in their opcode field, right? So this will be opcode for type 1 and type 2. Now type 3 instruction will have 10 bits for operand. So the opcode will eventually get expanded. Here the number of bits available for opcode will be 6. Yes or no? Number of bits available for opcode will be 6. Now finally what will happen? Sir, in type 4 instruction the number of bits available for opcode will be 10. Because 6 bits will be required for operand. So number of bits available for opcode will become 10. So you now understand that how you can solve the problem. Once you know this, now once you identify the structure that how many bits will be required for the in the opcode field for an individual type of instruction, you will be able to identify that in what order this particular question needs to be solved, right? So type 4 4 4 4. So 4 4 for this two. So you can choose either type 1 or type 2. Now in type 1 there are 3 integer registers. In type 2 there are 2 floating point registers. So integer register 1, integer register 2, integer register 3. It's the basic format. Floating point register 1, floating point register 2. In this particular case, there will be one integer register, one floating point register. In this particular case, there will be only one floating point register, right? So, sir, using 4 bit, now we can solve the equation. Using 4 bit, how many total can be represented? Sir, 2 raised power 4, that is 16 can be represented. How many do we require? Sir, type 1 instruction are 4. Only 4 type 1 instructions are required. So, you know, 16 are the total possible, required are 4, therefore 12 will be free. 12 will be free. Again, out of this 12, out of this 12 combinations, some will be allocated to type 2 because the opcode field is not expanding. So please try to understand. In type 2, you require 8 instruction. In type 2, you require 8 instructions. So let's assume that first we allocated this 4 to type 1. Then out of this 16 patterns, first we allocated 4 to type 1. Then from the remaining 12, so the available are 12. Okay, required are 8. Therefore, free will be how many? So free will be 12 minus 8. That is 4 combinations will be free after allocating all type 2 instruction. Right? Now you need to identify how many type 3 instructions can be formulated. So please try to understand how many free opcodes of 4 bit. Sir, the free of 4 bit are 2. Sorry, free of 4 bit are 4. The opcode field is expanded by how many bits? Sir, opcode field is expanded. See, this is important. Opcode field is expanded by 2 bits. Therefore, this 4 will get multiplied by 2 raised power 2. This 4 will get multiplied by 2 raised power 2. Because, see, please try to understand. If you have one combination 0 and there are some free patterns 0, 1 or I would say 0, 0, 0, 1, 1, 0, 1, 1, then the 0 can be combined with 0, 0, 0 can be combined with 0, 1, 0 can be combined with 1, 0, 0 can be combined with 1, 1. So each one of this 4 combination can be combined with 2 raised power 2 different combinations of 2 bit. Therefore, overall number of combinations will be total available will be 4 into 4, that is 16, right? How many are required? So how many type 3 instructions are required? How many type 3 instructions? So type 3 category consists of 14 instructions. So we require 14. So required equals to 14. Therefore, free will be how many? So free will be overall 16 type 2 type 3 instruction could be formulated. Out of them 14 are required. So you will be left with 2 free combinations. So please try to understand this 6-bit opcodes which are free. 6-bit free opcodes. 6-bit free opcodes are 2. Only two patterns of 6-bit are free. Only 2 patterns of 6-bit are free. With respect to type 3, the opcode field is being expanded by how many bits? The opcode field is being expanded by how many bits in type 4? Sir, the opcode field is getting expanded by 4 bits. So basically, this 2 combinations will be multiplied with 2 raised power 4 different patterns of 4-bit, and ultimately the number of combinations will be 2 raised power 16, that is 32 free opcode patterns are available of 10-bit. So there are still 32 patterns of 10-bit which are not with respect to, in which the initial 4 bits are not with respect to type 1 or type 2, initial 6 bits are not with respect to type 3. Therefore, there are 2 free bits, there are 2 free patterns. Yes, Akhil, definitely I'll do that. Please let me finish this particular series for this week. I'm very sorry, Akhil, but the idea is that I'm already having 2 or 3 paid classes, and apart from that, it was previously planned. So don't worry. From the first or from the very first or from the first or second of November, I'll start with the machine learning. Don't worry about that. I already planned from the first or second of November. I'll start the remaining topics of machine learning. Please wait for a few more days. You have already waited patiently for those many days. Please, few more days, and then we'll cover all. And you all know that we need to cover the questions also. And you all must know that IISc Bangalore has eventually provided with the sample paper for GATE DA. So we'll also analyze that, and we will try to create the questions on that particular pattern, right? So that's the idea. So free opcode possibles are 2. Now the opcode bit is expanded by 4 bit, therefore 2 into 2 raised power 4, that is 32 different patterns are available, in which they are not with respect to type 1, type 2, type 3. So those all can be allocated to type 4 instruction. So it is what that is what is being asked in this particular question, that if type 4 instructions are n, then the maximum value of maximum value of n can be. So maximum value of n can be 32, because you cannot have more than 32 instructions of type 4, because if you try to do so, then either you will not be able to specify the floating point register, or you will breach in the boundary of either type 1, type 2 or type 3 instruction. Clear? So that's the very first question based on instruction format. So generally a student will think that, sir, this question is not in the form of 0 address instruction, 1 address instruction, 2 address instruction, 3 address instruction. The question need not be in that particular format. Yeah, that's what I said, Akhil, right? So I completely understand your problem. So we'll try to solve that. Don't worry. Right? So that's the idea, that all the questions need not be in the particular format of 0 address, 1 address, 2 address, 3 address instruction format. They may be, it's just a name. Whether you call it 0 address instruction, 1 address instruction, or you call it Vishal Ratia instruction, or you call it Tushar instruction or Akhil instruction, it doesn't matter. It's just a name given to that particular format, and that's it. Right? So let's look at the next question. So the second type of question that can be framed from this particular topic of machine instruction and addressing mode is actually related to the concept of addressing mode. So you must know all the different types of addressing modes. So implicit or implied addressing mode is not that important. No question can be framed on that particular concept. The questions can be framed based on the immediate addressing mode, based on register addressing. No direct question will be there on the register addressing mode, but register addressing mode may be a part of one instruction. But the direct question can definitely be asked related to immediate addressing mode. Apart from that, memory direct addressing mode, register indirect addressing mode, memory indirect addressing mode, and PC relative addressing mode, index addressing mode, base register addressing mode, and auto index addressing mode, that is auto increment and auto decrement addressing mode. From any of this 9 different types of addressing mode the question can be framed. So look at this particular question, that what are the different addressing modes which are being used in this particular question, right? So consider a 3-word machine instruction. Generally we assume that the instruction will be of one word. Generally we assume that the instruction will be of one word, but if specified in the question, then the instruction can be of any size. Sir, Diplav, you can actually connect me on the Telegram group. We'll try to sort of find some solution. I may provide my notes if they may help. Right? So anyway, so let's look at this 3-word instruction. Please try to understand the why am I discussing this particular question and why did I choose this question is that how actually a 3-word instruction is executed using the machine. Please try to understand what will be the size of instruction register. The size of instruction register will be only one word. The size of instruction register will be only one word, and whatever is being executed must be present in the instruction register. So if you guys are thinking that this 3-word instruction will be available in the CPU at the same time, it is not going to happen. It is not going to happen. At a time, only one word of this 3-word instruction will be present in the instruction register, and that's the idea. Generally, whatever the number of words are in the instruction, the opcode field will never be of more than one word. The opcode field will never be of more than one word. So when, let's assume that this is a 3-word instruction, so these are the 3 different words: first word, second word, and third word. Intuition, please try to understand. I know that many of you can provide the solution of this particular question, but it is not important. See, when I am discussing only 5 questions of machine instruction and addressing mode, then my idea of discussing these questions will be that you understand everything related to that particular chapter by the discussion of these 5 questions, right? So password instruction. So the opcode field in any instruction can never be of more than one word. So, and opcode field is always present in the first word of instruction, even if the instruction size is of more than one word. So the moment you will fetch the first word of the instruction, you will know that what type of instruction is this. So based on the type of the instruction, you will know that what will be the size of this instruction. Based on the type, let's assume that there is a pattern 0, 0, 1, 0, 1, 0, 1, 1. Now, let's assume that this pattern is one instruction. The moment you identify that yes, this is a valid instruction, the control unit will know that this is an instruction for the execution of which 3-word information will be required. So CPU will know that ultimately this is not all related to this particular instruction. We need to fetch 2 more words of this particular instruction in order to execute this particular instruction. Clear? So that's the first idea. Consider 3-word instruction, and what is being specified in the question is, let's try to understand that the first operand, okay, there are, so you can do you realize that this is the opcode, this is specifying the first operand, this is specifying the second operand. So basically it's a 2-address instruction. Basically it is a 2-address instruction. So this first address will work as a source plus destination. In 2-address instruction, the first address by default, if nothing is specified in the question, then the first address will work as source as well as destination, and this will be the source 2. So source 1 plus destination, this will be source 2. Okay, sir. In 2-address instruction, that's what happens. If I write add R0, R1, then what do? Sir, R0 value will be added with R1. So R0 will work as source 1 as well as destination. So stupid thing to discuss, but yeah, everything needs to be discussed, so cannot be avoided. So the first operand as well as destination. So it's specifying that the first operand as well as destination. So it will be a source as well as destination. Is this? It uses what? Do you realize what type of addressing mode is this? What type of addressing mode is this? We don't know, sir. I'm not able to understand. So there is a register name written inside a bracket, and before that some value A is written. We don't know what this A is. In the question, everything is being specified. If I write something like this, do you know what does it mean? Sir, it is either index addressing mode or base register addressing mode. The representation of both base register addressing mode and index addressing mode will be same, right? So that's the idea, that this is something which we already know. But what is this A? If A is representing to some other information, then we don't know. Here, what is this 2? So this 2 in basically in index addressing mode, this 2 will be the base address, and this R1 will be the index value. This R1 will be the index value. So that is what is being specified here, that A R0 uses the index addressing mode, right? So in index addressing mode, register R0 is written here. R0 is actually the index register. So here it is saying index addressing mode, R0 as index register. So R0 is the index register, then this A is actually trying to specify the base address with respect to that particular address. So with A, you will add the content of register R0 and you will get the effective address. Based on that, you will get your operand. Now the second operand, it will only be source. Now this first operand will be operand as well as destination. The second operand will only be source. Is directly, we know @ will represent indirect memory indirect addressing mode. So this is memory indirect addressing mode. Now from here we know that A and B has to be the addresses. This is the base address, this is also the address with respect to memory indirect addressing mode. Uses indirect addressing mode. Yes sir. What type? Memory indirect, because @. If it is register indirect, then within the bracket we will write the name of the register. So it is not register indirect, it is memory indirect. A and B are memory addresses. Yes sir, we know it, right? Now what else is being specified? So for you, the instruction may look like this, but the assembler, when assembler is trying to convert this instruction into binary, the assembler may eventually places the information at the different in the different words of this instruction. So what is happening? A and B are the memory addresses. You all know that to specify a memory location, more number of bits will be required. Registers are limited. Addressing modes in the processor are limited, right? So addressing modes will be how many? 15, 20, 30, not more than that. So you don't require more than 5 bits to represent any of the addressing modes supported by the processor. Registers will be how many? Sir, more than maximum 200. So 8 bits are sufficient to specify the register. So 8 bits are gone for registers. Let's assume 5 bits are gone for addressing modes. Remaining bits are still available for the opcode. Remaining bits are still available for the opcode. Right? So that's the idea. Now A and B are the memory addresses. They will require more space. They will require more space. So A and B are the memory addresses. Therefore, the more space is required for them. So more number of bits are required. So A is stored in the second word of the instruction. B is stored in the third word of the instruction. Right? So this is what is being said. A and B are the memory addresses residing at the second and third word respectively. The first word, this first word contains so many information. The first word of the instruction specifies the opcode, the index register, the register number, and the designate index register, and the source and destination addressing mode. So this particular word will specify the opcode. This will specify the register which is being used for indexing, and the addressing mode for first address field, addressing mode for second address field. So all of them are specified in the first word of the instruction itself. Good evening, Mehdi. Right? Now, what does it do? During the execution of add instruction. Now what is, sir, execution? During execution, please try to understand, if it is a 3-word instruction, then in order to fetch this 3 word, 3 memory cycles will be required, because in 1 memory cycle you can fetch only 1 word. If it is a 3-word instruction, then to fetch this instruction, 3 memory cycles will be required. In 1 memory cycle, 1 word will be fetched, but it is not talking about fetch, it is only talking about execute. So during execution of add instruction, the 2 operands are added. Obviously, this first operand, this second operand, these 2 operands are added and stored in the destination. Destination is being specified by the first operand, that is the path. Yeah. Everything is given in the question. Everything is given in the question. You don't need to worry about anything. So what will be the significance? Sir, if I want to understand that how this addition will be executed, so first operand is using First operand is using index addressing mode. Sir, how do we get the effective address? Sir, the address present in the address field of instruction plus the content of register R0 will give you the effective address. With respect to index addressing mode, base register addressing mode, and PC relative addressing mode, one arithmetic operation needs to be performed in order to obtain the effective address. Based on that effective address, when we access the memory, you get your operand 1. Right, sir? Now, how do we get the second operand? Second operand is using memory indirect addressing mode. So B is a memory address, and at that particular memory address, the effective address is available. So the content of memory location B will provide you the effective address. Now, based on that effective address, when you again access the memory, you will get your second operand. Now, the third thing that you need to do is, sir, this result needs to be stored at the destination. The destination is same as first operand. That means the content of location A plus R1. This is your effective address. So content of this location will be updated. The content, that is the memory content of this address, will be updated by this result. Now please try to understand. We are not fetching the instruction. We are not counting the number of memory cycles required for the fetching. Here it is asking the number of memory cycles needed during the execution cycle of the instruction. The number of memory cycles needed during the execution cycle of instruction. Sir, how many memory references are performed? How many memory references? Sir, 1 is this to catch the first operand. Now, in the calculation of effective address, this value is already present in the instruction, no memory access. This is the content of register, no memory access. So your effective address with respect to first operand will be calculated without any memory access, but to get the first operand you will have to access the memory. So one memory access. Here, to get the effective address itself, you will require one memory reference because it is memory indirect. The effective address itself is present in the memory. So in order to obtain that effective address, you will require one memory access. And finally, based on that effective address, memory will again be accessed. Memory will again be accessed to fetch the operand. So, sir, that's it, right? Then finally, to store the result, the result needs to be updated in the memory at this particular location. So again, one memory access will be required. So overall, how many memory accesses? Sir, overall 4. 1, 2, 3, 4 memory accesses are required. Memory cycles are required to execute this instruction. If somebody asks me how many overall memory cycles are required, sir, obviously answer will be 7. Obviously, answer will be 7 because there are 3 words in this instruction. You cannot execute the instruction until you fetch all the words of that instruction. One word can be fetched in one cycle, therefore 3 memory cycles for fetch. But it is not asking about the number of memory cycles in the instruction cycle. It is asking for the number of memory cycles in the execution cycle. Right? In the instruction cycle, fetch will be included as well as execution will be included. Clear? So the answer for this question will be 4. That is option B. Okay, sir. Let's look at the next question. This is a typical question. Generally, student face difficulty in understanding that what is actually happening here. Therefore, I consider this question. The similar type of questions based on the operation can be seen in the GATE PYQ, but they can be solved easily. They are not tedious. Generally, students are not able to understand this particular question. So let me explain that. Following table indicates the latencies. Latencies means delay. Right? Delay of operations. Latencies of operations between the instruction. This term itself is confusing. Most of the students are not able to interpret the question correctly. So the following table indicates the latency of operations between the instruction producing the result and instruction using the result. What does it say? If one instruction is producing the result and the instruction that is producing the result is an ALU instruction, the instruction that is producing the result is an ALU instruction, and the instruction which is using the result produced by that ALU instruction is also an ALU instruction, then in between those two instructions there must be minimum delay of 2 cycles. There must be minimum delay of 2 cycles. That means you cannot do one thing. Let's try to understand this. If I say add R1, R2, R3. So this instruction add is an ALU instruction and it is producing the result in R1. If there is another instruction, let's say subtract, which is using this result R1, then please try to understand, because it is using, it is producing, it is using, right? Producing and using. So what does it mean? Sir, this is an ALU instruction, there is also an ALU instruction. One ALU instruction is producing the result, another ALU instruction is using the result. So in between those two instructions, there must be minimum delay of 2 cycles. There must be minimum delay of 2 cycles. You cannot execute this subtraction after this addition immediately. You cannot immediately perform the subtraction operation after this addition if it is using the result produced by the first instruction. Okay, sir. So similarly, if an ALU operation is producing the result and a store operation is using that particular result, then also 2 cycles must be there. If load instruction is producing the result and ALU operation is using that result, then only one delay, the delay of only 1 cycle is required. Now, if load is producing the result and store is using the result, then no delay is required. Let's look at the actual question. Consider the following code segment. Consider this are the code. Consider the following code segment. Now it is asking what is the number of cycles needed to execute the above code segment. What is the number of cycles needed to execute the above code segment? Assuming each instruction takes 1 cycle to execute. So if each instruction takes exactly 1 cycle to execute, how many instructions are there? Sir, 1, 2, 3, 4, 5, 6, 7. So if no delay is required in between the instruction, then for the execution of this particular instruction, 7 cycles will be required, as there are 7 instructions. But apart from that, there will be some delay which you will have to include before you perform the operation. So let's try to understand what is happening. Let's try to understand the dependency. Sorry. Okay, so let's try to understand. So this load R1 from memory location local. So it is producing the result in R1. Sir, it is producing the result in R2. Now, but this is not using, there is no dependency. Sir, it is using the result R2 as well as using the result. So add R1 and R2 and save the result in R1. Now multiply R1 and R2 and save the result in R3. So it's opposite. Please try to understand. This to our source. This is your source 1, this is your source 2, this is your destination. Source 1, source 2, destination. Clear? Now, so let's try to understand this particular concept, that this particular addition instruction is an ALU instruction. It is using the result produced by 2 load instruction. So if the load instruction is producing the result and ALU operation is using that particular result, then the delay of 1 cycle is required. Please try to understand. We need the value of R1 as well as R2. So this load will produce the result in R1. Before we start the execution of this addition, already 1 cycle is elapsed, because already 1 cycle is elapsed when we were executing this second instruction. But this addition also requires the output of this previous instruction, which is a load instruction. Now the delay of 1 cycle must be inserted between this load and add instruction. So first of all, one delay will be there, right? So this delay is already there. Now let's try to understand. It is producing the result in R1. It is decrementing the R2. Please try to understand. This decrement is an ALU instruction. It is trying to decrement the value of R2. Sir, it is trying to decrement the value of R2 means it is using the R2. R2 is produced by this load instruction. So this is ALU, this is load. Between load and ALU, there must be delay of 1 cycle. That is already there. We have already included that. So already between these 2 instruction, load and decrement, already there is a delay of 2 cycles. Already 2 cycles have passed between load and decrement. Therefore, you don't need to worry about that. You can simply execute it. You can simply execute it. Now, this is trying to decrement R1. So do you realize that there is a dependency? So it is producing the result in R2. It is producing the result in R2. There is a decrement operation which is decrementing the value of R1, which is decrementing the value of R1. So the R1 value is produced by this add instruction, right? So in between this two instruction, add and decrement, how much delay should be there? Sir, add is an ALU instruction, decrement is also an ALU instruction. So there must be a delay of 2 cycles. There must be a delay of 2 cycles. The delay of 1 cycle is already there because of execution of this decrement R2. The delay of 1 cycle is already there because of this execution of this decrement instruction. Now, the delay of one more cycle needs to be included between decrement R2 and decrement R1, so that there is a delay of 2 cycles between add and this decrement R1. So one more cycle will be wasted before you can execute this decrement R1. Now this multiply R1 is, sir, it is multiplying R1 and R2. So anyway, this is producing the result in R1. This is producing the result in R1. So there is a direct dependency. So this multiply cannot be executed immediately after this decrement R1. There must be a delay of 2 cycle. There must be a delay of 2 cycle between this decrement R1 and this multiply, because both of them are ALU. So if one ALU operation is producing the result, another ALU operation is using that result, then there must be a delay of 2 cycles. So this delay of 2 cycle must be included. So again, the delay of 2 cycle will be included. Finally, it is producing the result in R3. Finally, it is producing the result in R3, and that particular R3 value is being used. That particular R3 value is being used. So this is an ALU instruction, this is an store instruction. So ALU, one is ALU instruction, another is a store instruction. Again, there should be a delay of 2 cycle. Again, there should be a delay of 2 cycle, right? So in between this two instruction, again, a delay of 2 cycle must be included, right? So this is the overall time. So 7 cycles are required. 7 cycles are required for the execution of this 7 instruction. Apart from that, the delay of 6 cycle will be included. So the overall number of cycles, the overall number of cycles required for the execution of this program will be 13 cycles. 7 cycles for the execution of 7 instruction. The delay of 6 cycle will be included because of this dependency. Delay of 6 cycle will be included because of this dependency. Therefore, the correct answer will be 13. Clear? That's for question number 3. Let's move for the question number 4. This question is related to shift operation. This question. So basically, when we discuss the concept of type of instruction, we'll have data transfer operation, load, store, move. We all know them. Data manipulation instruction, that is addition, subtraction, bitwise and bitwise OR. It's okay, right? Apart from that, there will be some special data manipulation instructions such as shift and rotate, shift and circular shift. Shift may be logical shift, shift may be arithmetic shift. So the question may be asked related to logical shift, arithmetic shift. The question may be asked related to rotate operation. So those are the simple operation. I'm just trying to explain this concept of shift because it is using some random thing in this particular question. Otherwise, the shift will be simple, that you will shift all the bits of the register either left side by 1 bit or right side by 1 bit. If it is rotate, then you will rotate the bits of the register towards left side, that is towards clockwise, or towards right side, that is towards anti-clockwise. So that's the idea. So it's a simple operation, nothing much to do. But in this particular question, something else is being done. So most of the time, again, the students are not able to understand this type of question. So please try to understand. Please try to understand. Why am I discussing this question? There is nothing new in this question number 3. You may think that, sir, something absolutely weird is happening here. No. The question may specify some new things in it, and then they may ask you to utilize the information available in the question in order to reach to the solution. So that's what happened in the question number 3. the exactly same thing is happening in the question number 4. You don't have any such instruction implemented in your machine. So therefore, you don't know this instruction. You don't know this instruction. You may think that, sir, what the hell is this? We never saw anything of that particular type. Yes, so it's okay because it's a new instruction. You can understand that the professors are actually trying to implement a new type of thing by using certain things which are already available in the machine, right? So consider a new instruction named branch on bit set, BBS, branch on bit set. Means if a particular bit is set, then you will branch to the target address. If a particular bit is a set, then you will branch to the target address. This is the meaning of this instruction, right? We don't know this. The definition of this instruction is given in the question itself. The instruction BBS, so branch on bit. So which particular bit should be set? So within this register, if the bit at position pose is set means 1. In this register, if the bit at position pose is set, that is if it is 1, then we will jump to this particular address which is defined in the label. Then we will jump to this particular address which is defined in label, and that's what is being defined in the question. So because of execution of this, the instruction, this jumps to label, will jump to label in what condition? Will jump to label if bit in position pose, if this will define a number, that which particular position we are talking about. If bit in position pose of register reg is 1. So in this register, if the bit at position pose is 1, then you will jump to this particular label. That's the simple meaning of this instruction, right? So let's try to understand. If I simply write BBS R0 5 200, what does it mean? Sir, in register R0, so in register R0, let's assume it's a 8-bit register. Let's assume it is 8-bit register. So this is your position 0, this is your position 1, this is your position 2, this is your position 3, this is your position 4, this is your position 5. So we are talking about this particular bit. This is your position 6 and this is your position 7, 0 to 7, 8 bits. So in this register R0, if this value is 1, then we will jump, if this is 1, then we will jump to 200. If this is 0, then we will not jump to 200. That's the simple aspect of this particular question. And we want to implement this same thing by using something which are already available in our system. Now the idea is, here it is saying that the register is 32-bit wide. So it's okay. I just explained in a smaller size register, there's no problem. So basically the register is 32-bit wide. That means the value of position may vary between 0 to 31. Yes, wide. The bits are numbered from 0 to 31. That means the position will be anything between 0 to 31. In this particular case, the position can be anything between 0 to 7. So if the register is of 32-bit, then the position can be anything between 0 to 31. Now, in position bit in position 0 being the least significant. Yes sir, we know that we generally define the positions from the least significant side towards most significant side. Now consider the following evaluation of this instruction on a processor that does not have BBS implemented. Now what are they trying to do? They are trying to implement this instruction on a machine. They are trying to implement this instruction on a machine in which BBS is actually not implemented, right? Now in order to do that, what are they doing? They are using this, that we will eventually have the content of register, will perform the bitwise AND operation of the content of this register with a mask. Please try to understand. Let's think in terms of 8-bit only. If this is your register R0, if I define a mask, then my only situation should be, my only understanding should be that if I want to check whether the bit at position 5 is 1 or not, the bit at position 5 is 1 or not. So in this mask, the bit at position 5 should be 1, all other bits should be 0. All other bits should be 0, because if we are performing the bitwise AND operation of this register with this mask, then the result will either be 0 if the bit at position 5 is 0, then the result will be 0. If the result at position, or if the bit at position 5 is 1, then the result will be non-zero, because see, it only depends on this particular, it only depends on the value at position 5 in register R0, because every other position will become 0 because of the zeros in the mask, because of the zeros in the mask. Now this value may also become 0 if the value at position 5 in register R0 is 0. If it is 1, then 1 and with 1 will be 1, that is, it will become non-zero. Clear? So that's a simple aspect, that we need a mask in which the bit at position pose should be 1, all other bits should be 0. All other bits should be 0. So basically it is actually doing what? Register. It is performing the AND operation of the content of register with this particular mask, and it is storing it into a temporary register. It is storing it into a temporary register. Then it is saying that will branch to label if the result in the temp is non-zero. It will be non-zero only if the bit in position 5 is 1. Because if it is 0, then all other are already 0 because of the zeros of mask. And if this two are 1, then the result will be non-zero. Otherwise, result will be 0. So branch to label if temp is non-zero. So the only thing is that in this particular question, we are trying to define a mask such that in that particular mask, the bit at position 5 is 1, all other bits are 0, or the bit at position pose is 1, all the other bits are 0. So that's the idea. The variable temp is a temporary register, okay, for correct emulation. Now, the variable mask must be generated by what? How do we generate the variable mask? Please try to understand. Sir, if we simply put this value pose in the mask, is it going to make any difference? No, sir. If I write 5, if I store 5 in the mask, then 5 will be nothing but 101. This is wrong. If I make all the bits of this mask as 1, then also it will be wrong. Now it is saying that, sir, make all the bits at 1. So initially it is saying that make all the bits of mask as 1. So because it is inserting this value 1 1 1 1 1 1 32 bits. So 4 4 4 4 4 8 times. All of them are 1. So we are inserting all ones into the mask, then we are left shifting them by pose. So let's assume if I make all them 1 and then I left shift it by 5 bit, then ultimately this 3 bits will be 1. Remaining will become 0, is okay. But this 3 bits will still be 1. So it is again incorrect. Sir, the only correct idea is that make the very least significant bit of mask as 1. Right? So that's the idea. Let's make it 1. Now, if your position value is 0, then you will not left shift it. If your position is 0, then you will not left shift it. That means you are checking whether the bit in register at position 0 is 1 or not. So if you left shift it by 1, then this 1 will come here. That is, the bit at position 1 in register is 1 or not. Because of this left shift, it will become 0. So because of this left shift, 0 will get inserted from the right hand side, and this 1 will get shifted by one position towards left, right? So it will reach to that particular position in the mask at which we want to check whether the bit in the register is 1 or not. So the correct answer will be option A. Clear? I hope there will be multiple ones in this particular case. This is not with respect to the position. We are storing the value into the mask. So no. So 8 means if we store 8 into the mask, it does not mean that the bit at position 8 will be 1. The value 8 will be stored in the mask. If I do this, then 1111 will be stored in the mask. So that's again wrong. So all of them are wrong. They are not justifying with the concept. The only thing that is correct is option A. Now, the last question, which is related to PC relative addressing mode, this is damn easy, but you just need to understand in PC relative addressing mode, there are some silly mistakes which can be committed by these students. So please make sure that you always remember one thing, that by default, if not specified, memory will always be byte addressable. If not specified, memory will always be byte addressable. That's what we know. Now, in the PC relative addressing mode, offset will be always with respect to address of the next instruction. That's the next thing which you should know. Apart from that, the offset in the PC relative branch instruction can be positive as well as negative. So these are the three things which are important from the concept of PC relative addressing mode. Consider a RISC machine where each instruction is exactly 4 byte long. Now, if instruction size is 4 byte, conditional and unconditional branch instruction, whether it is conditional or unconditional, does not matter. It uses PC relative addressing mode. So if there is any branch instruction, then it will use PC relative addressing mode. Do you know that this add is ALU, subtract is ALU, comparison is data manipulation instruction? This branch equals to branch on equal to 0, branch on equals to 0. So if R1 is equals to 0, you will jump to offset. Clear? So that's the idea. Branch equals to 0, not equals to will be not equals to 0. So this is a branch instruction. This is a branch instruction. It's actually a conditional branch instruction. This is a conditional branch. Right? So if it is a conditional branch, then definitely it is using PC relative addressing mode. It is using PC relative addressing mode. So in PC relative addressing mode, obviously this is the offset. So it will specify that from the current address, how many bits ahead or backward you want to move. So please try to understand, when we are executing this branch instruction, PC value will have the address of the next instruction. PC will have the address of the next instruction. So please try to understand, just for the understanding purpose, let's assume that the address of instruction I is 100. Now, in the question it is given as the instruction is 4 byte long. Let's check whether it is specifying that the memory is byte addressable or word addressable. So let's look further. With offset specified in bytes to the target location of the branch instruction, it's okay, we know. Further, the offset is always with respect to address of the next instruction. We know the offset will always be address of the next instruction, because the offset will always be with respect to current value of program counter, and the program counter is actually pointing to the next instruction, right? So we know this address of the next instruction in the program sequence. Consider the following instruction sequence. Okay, now if the target of the branch instruction is I, so it is saying that if at all this branch is taken, then we need to jump to this address I. If at all this branch is taken, then we need to jump to this address I. That means the PC value should become 100 because of the execution of this instruction. If the branch is taken, PC value should become 100 if the branch is taken. Okay, sir. Nowhere it is being specified that the memory is word addressable. So if the instructions are of 4 byte and if nothing is specified, then the memory will be byte addressable. Therefore, I plus 1 will be available at address 104, I plus 2 will be available at 108, I plus 3 will be available at 112, and the address of the next instruction will be 116. Address of the next instruction will be 116. Sir, what will be the current value? What will be the new PC? Sir, new PC will be PC plus offset. New PC will be PC plus offset because of PC relative branch instruction, right? So sir, what is the current value of PC? Current value of program counter when we are executing this PC relative branch instruction is 116 plus offset. Because of this, the new PC value which is required is the address of instruction I, that is the new PC value has to be 100. Therefore, what should be the value of offset? What should be the value of offset? So the value of offset will be minus 16. The value of offset will be minus 16. Please remember, in PC relative addressing mode, offset value may be positive, offset value may be negative. Right? So these are some important questions from the topic of machine instruction and addressing mode. So what all you need to understand, sir? Instruction, the questions of instruction format, the questions of addressing mode, the questions of shift rotate instruction, fourth type of instruction will be, if a new type of question is given, then you must be ready to interpret that. I hope you understand that there is nothing new in this particular question. But if you think that we don't know what is BBS instruction, then you may skip this question or you may leave this question. It's not a good approach. Try to read the question. The question itself will specify if something new is being used in that particular question. Here also, in order to execute this particular program, only 7 cycles will be required if each instruction takes 1 cycle. But some cycles will be wasted because of this dependency which is provided in the question. How? Now you may say, sir, is it necessary that always between 2 ALU instruction we will include the delay of 2 cycles? No, this is being specified in this particular question. So use the information available in this question to solve this question, right? So don't be afraid of any new information that is present in the question. Try to interpret that information, and this time should be given when you are trying to learn the subject. This is not the time which you will spend in the examination hall. Try to learn or try to overcome this problem of leaving the question while something new is present in that particular question. So try to avoid that situation. Try to interpret the question, and slowly you will become comfortable in all this type of questions. Okay. So that is it. Last one is PC relative type of, PC and auto increment, auto decrement. The only type of question that I did not include here is auto increment, auto decrement. That will also be related to effective address calculation. Before effective address calculation or after effective address calculation, the content of the register may get incremented or decremented. So it may be pre-increment, post-increment, pre-decrement, post-decrement. So that's a simple concept. If you know the concept of register indirect address, or if you know the concept of register indirect addressing mode, then you already know the concept of auto increment and auto decrement addressing mode. There's nothing new, just the value needs to be incremented, right? So, or decremented. So that will be all for this very fast session. I have taken the 5 questions, 19 more questions to go. Tomorrow we'll discuss the 4 most important questions of ALU, data path and control unit. Again, the students are afraid of this particular topic. I'll try to explain that how the questions of this particular topic can be solved. So we'll discuss only 4 questions. It's a small topic. Very rarely the questions are asked from this particular topic, but if at all a question is asked, then the nature of that question will be very simple. The nature of the chapter may be very complicated, very typical, but the questions those will be asked from this particular chapter will be damn easy, right? So that's the next thing. So this 2 will make the 9 questions. So I'm telling you that overall I'll discuss 24 questions. Overall I'll discuss 24 questions of COA. Then I'll have a test or a mock test of 24 questions. Those 24 questions will be completely different. Those 24 questions will include all the aspects or all the concepts of computer organization and architecture. So please don't forget to participate in that particular mock test that will be conducted I believe on the next Monday or Tuesday. I'll let you know the exact date. The schedule has been created, but I myself don't remember that what is the exact day for that particular mock test. So in this week, for the next 5 days, we will be discussing the next 19 questions, the remaining 19 questions of COA, and then will appear for that particular mock test to analyze that how well we are performing in the computer organization and architecture, right? So this is it. This is my Telegram group. If you guys have any doubt, you can ask there. Who asked, Sir Deplav? This is the Telegram group. If you need the notes or some other help, then you can talk to me. We'll find out some solution. That will be all. If you liked the video, then please hit the like button. If you are new to the channel, then subscribe for the channel and press the bell icon to get such amazing videos of computer science branch. That will be all. Thank you very much. Keep learning. Good night. Take care.